Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of bilinear upsampling and downsampling, specifically addressing the often overlooked issue of pixel grid alignment and the infamous GPU half-pixel offset. It's a surprisingly complex topic.
Absolutely. I've always found image resizing a bit of a black box. What's the core problem we're tackling here?
The core issue is the lack of a single, universally accepted definition of bilinear upsampling/downsampling. This ambiguity leads to inconsistencies across different libraries and implementations, even causing significant bugs in major frameworks like TensorFlow, as highlighted in the article. Imagine spending 60 days debugging something like that.
60 days? Wow. So what are the different interpretations of bilinear resampling?
Primarily, it boils down to how we handle pixel grid alignment. One approach aligns pixel centers, while the other aligns pixel corners. The choice affects how we calculate filter weights during upsampling and downsampling. It's subtle, but the consequences are significant.
And this is where the half-pixel offset comes in, right? I've heard that term before in GPU programming.
Exactly. GPUs typically use a half-pixel offset convention, aligning pixel corners. This simplifies calculations and ensures consistent behavior across different resolutions. It's a clever solution that avoids many headaches. But it's not always intuitive at first glance.
So if GPUs use this half-pixel offset, why is there still so much confusion?
Because CPUs and other image processing libraries don't always adopt the same convention. The article emphasizes the importance of consistency. Using different conventions for downsampling and upsampling can lead to that infamous pixel shift we see in the GIF, a half-pixel offset between the original and the resized image. It's a visual representation of the underlying mathematical inconsistencies.
Right, I see. So what's the recommended approach?
The article suggests using the half-pixel offset convention as a default, aligning pixel corners. It simplifies things considerably and aligns with the GPU's standard practice. It's a robust and efficient approach.
But what about the signal processing perspective? The article mentions zero insertion and filtering. That sounds complicated.
It is a bit more involved, but it provides a deeper understanding of what's happening mathematically. Zero insertion essentially creates a higher resolution representation with gaps, and then filtering smooths out those gaps. It's a way to model the upsampling process formally.
Interesting. So different filtering techniques lead to different results, right? Some might be better at preserving detail, while others might be better at reducing aliasing.
Precisely. The choice of filter significantly impacts the final image quality. The article explores the trade-offs between different filters, highlighting the importance of considering the frequency response and aliasing artifacts. It's a balancing act between sharpness and smoothness.
And the magic kernel? Is that some kind of secret sauce?
Not really a secret, but it's a name given to a specific filter that achieves bilinear upsampling in a particular way. The article shows that it's essentially a combination of nearest neighbor upsampling followed by a specific bilinear filter. It's not magic, just a clever way to achieve the desired result.
So the key takeaway is consistency, right? Using the same convention for both downsampling and upsampling to avoid those pesky pixel shifts.
Exactly. Consistency in pixel grid alignment is paramount. Understanding the different interpretations of bilinear resampling and choosing the right approach for your specific needs is crucial. It's all about avoiding those frustrating bugs and getting predictable, high-quality results.
This has been incredibly insightful. Thanks for breaking down this complex topic.
My pleasure. And remember, listeners, always double-check your bilinear resampling implementations for consistency. Until next time, this has been Tech Bytes and News. Goodbye.
Bye-bye.